This morning, it's just a true honor for me to introduce once again people that you met yesterday that are good friends and both leading scientists in the field at a global level, people of courage and vision. We'll start with Dr. Jonathan Lungren.
Good morning, everybody. I don't know why they always give me the morning slot, but here we are again. It's good to be here once again. Everybody get a good sleep last night. That's a nice thing. Very bland title, Biodiversity and Food Production, but hopefully the content will not be so bland. Biodiversity, what is this? What is it that we're talking about? We're talking about life. Okay, that's what biodiversity is. And it's a fancy term, but it means animals, plants, fungi, microbes, bugs, especially bugs. And how those things interact. And why is it important? We don't like biodiversity just because biodiversity is great, right? It's because biodiversity does things. All right, this is the cogs on the wheel of an ecosystem. And what you guys are working in is not a farm, it is an ecosystem. All right? And you're not in control all the time. The bugs are. The biodiversity is in control. So that control element is so important, right? Because that's what we strive for as a human race. We learned so much from Fred yesterday afternoon about, the mentality, the philosophy behind, who's at the wheel here. And I think that, why biodiversity is so important is because no matter throughout human history, whenever we've tried to replace it, whenever we've tried to outsmart it, Mother Nature turns around and kicks us in the crotch, right? I mean, that's not an opinion, that's documented fact, time and again, all right? So guess what's going to happen, when the next bag with the next genetically modified trait that we're going to, design, what's going to happen? Biodiversity is going to find a way around any problems with that thing. How do you know what biodiversity is? Well, you know what? I don't know that we ever really will get a full handle on what biodiversity is in a particular habitat, but we can do a hell of a lot better than we are right now. And you do that through bioinventories. And there aren't very many bioinventories out there, okay? I mean, maybe occasionally you get a snapshot. Because what a bioinventory is you send out a huge team, you dress them up first, of course, and, oh, wait, no, there we go. Where's my laser? I don't have a laser on this thing. Oh, you rock. One more button. All right, there it is. Yeah, so you send out a team to a bunch of different locations, a particular habitat across a region, and every day that team of scientists has to collect as many different critters using all kinds of methods, and then you bring back everything from the field, and then you identify it under microscopes, okay? Or whatever technology that you're using. This is what we do for insects. And literally, and you'll hear about some of the inventories that we've conducted, hundreds of thousands of specimens that we end up having to site ID. That's a ton of work. And you know what? It's not sexy. There is no granting agency that's like, oh yeah, let's get some just basic information on the critters that are out there. That sounds really good. That's going to advance our agenda. But this is fundamentally, without these inventories, without knowing what's out there, how do we know, number one, who's working and how they're interacting with each other, but also, how is it that our management is affecting these communities? How can we even get the first inkling of understanding the complexity of the natural world if we're not even looking for it? There was a guy, I'm going to butcher his name, Theodore Lager. And he came up with this book. And what he did is he went out into all these habitats all over the planet, and he dropped a cube, and then he counted all the critters. Okay? And he found just tons, just scads of diversity. Look at all these critters that he found in South Africa and in Costa Rica. And then he'd make these images, right? And it's very, very, very powerful to understand just in 1 cubic foot how much life is out there. And then Robert Krulwich, he's with Radiolab and NPR, did this for corn in Iowa. And as a Minnesotan, I can tease Iowans as much as I want to, right? A lot of corn. So it gives you, I mean, this is not a quantitative assessment by any means, right? But it does give you an idea of the diversity issue. So we've done some of the only bioinventories that exist, or the most comprehensive bioinventories that exist in a lot of agroecosystems. And we focused primarily in eastern South Dakota at this point, but now we're starting to expand out. In corn, we've identified not like what, 9 species, 8 or 9 species. We've identified 482 species of insects from corn. Wheat, 103 species, and we were just focusing on predators in that study. Soybeans, there's actually more insects in cattle dung than there is in soybeans. Does that tell you something? Just in cow crap in eastern South Dakota. What are we doing? This is Ryan Schmid. He's our first research scientist, but he started as a master's student, and then we sent him down to Kansas State. He got his PhD, and then we hired him back. He couldn't wait to get back. This was some of his master's work, and what he decided to do for his master's project is he wanted to go into prairies, pastures. These are ancestral habitats that have now largely been replaced in our region in eastern South Dakota with agroecosystems, especially with corn. And what he did is he got down on his hands and knees and he sucked up all of the insects on the soil surface, and he took a vacuum cleaner and he sucked up all of the insects that were in the vegetation, and he counted all the plants in these different habitats in order to compare how things have changed, how our diversity within these different habitats have changed. And this is what we found. We counted 270 or 2,000, almost 3,000 specimens of insects associated with this, breaking down into 340 species of arthropods, which is basically invertebrates or insects. We got 75 plant species, a pair of identical twins. Most of the diversity were little wasps. Wasps are the most diverse group of animals on planet Earth. And most people just count them as little gnats. They're actually small wasps that do not sting people. They sting other insects. They're called parasitoids. And every insect species has a wasp that stings only it. What happens is that the wasp inserts its egg inside of that insect host, and then the insect is devoured from the inside out by this developing wasp. Very cool. Very cool stuff. Doesn't happen. I mean, Hollywood's got nothing on entomology. So what we ended up seeing, and I left out a slide, is that cornfields actually have 25% of the diversity of the native prairie that they replaced. And you're like, okay, I'm a corn farmer. I'm responsible for this, 400 acres or whatever. What could possibly be the impact of that, right? But when you replace entire states, there's that crappy Iowa again. I mean, when you replace entire states with this mentality, right? Then suddenly you have huge impacts on biodiversity. And that's exactly what we're seeing right now. We're seeing diversity loss at a rate that the planet has never experienced before. This is not a bee problem, all right? This is the Holocene extinction event, is what we're calling it now. We are losing species at a rate that the planet has never experienced. We're losing entire habitats. Hey, buy some drain tile. What? You don't want to have to farm around that low spot this year? You're right, that sucks. Drain it. It's coming into South Dakota. Where'd the prairie go? We're down to 1%. And I can tell you on our own farm, half of our farm is native unbroken prairie, and it is a sight to behold. What a treasure that we have lost. Entire insect communities. A study just came out, last week another one just came out that documents this pattern. But a really good one came out a few months ago that said that in Germany over the last 27 years we've lost 70% of insects. Over 27 years, 70%. What do birds eat? What do reptiles eat? Come on. Butterflies, bats, birds, bees are all terrestrial mammals. We are losing species at an alarming rate. And there's the issue right there. As we've simplified our landscapes, entire states or regions, the only way to maintain, as you remove the biodiversity from that system, what do you do to maintain its productivity? You replace that biodiversity with a jug. And the more jugs you use, the more jugs you need. I don't care what the name is on the side of the jug. This is an addiction. The more you use, the more you need. And who wins in an addiction scenario? It's not the addict, is it? What's the solution to this biodiversity crisis that the planet is currently facing? Change agriculture. That's the only answer. That is the primary answer to this problem, and we better do it soon. Anything less than this, agroecosystems occupy 40% of the terrestrial land surface of our planet. This is a tool. This is our greatest tool for fighting biodiversity loss. But it's not just about numbers, okay? Biodiversity is great. Yes, it's about that richness of species and a habitat, but it's also about the way that these species interact. And the complexity of diversity is just so humbling. The function, what I mean by function is what services. Predation is a function. Pollination is a function. Detritivory is another function. These are functions of biodiversity. That depends on how these species are interacting. Not just that you've got them, but how they work together. So we went out into 53 cornfields and we did full bioinventories of everything that was living on those plants. And this hairball is what resulted from that. Every dot is a species. And when the species abundances interacted or were significantly correlated with one another, we drew a line. Look at the complexity of that community. And then as land managers, we think of this, right? We see this and we say, oh, this one right here, this one must be the pest. I'm going to focus everything I am on making sure that that one doesn't go crazy. When in reality, that pest, the only reason its abundance is going haywire is because of the stuff that's happening in this hairball, in this ball of spaghetti noodles. And that really our management needs to be focusing on this, not on this. What a completely different change from everything that we're taught as scientists, for sure, but also as land managers. Because each dot is a cornfield here. Don't worry, I'm going to talk about rangelands in a little bit. We're setting the stage. This is drama, right? This is drama. Every dot is a cornfield. This is species diversity in each of those cornfields, and this is the pest abundance. The density of pests in those cornfields. What this is saying is that when you have insect diversity in your cornfields, you do not have pests. When you eliminate that diversity from your agroecosystem, that's where your pests come in. Remember that ball of hair? This is the main components. I plucked them out to illustrate a point. This is a cornfield that has low pest abundance. Look at all of the interactions that are going on there. It's a functional community, isn't it? Not many pests there. This is a cornfield with high pest abundance. It's broken. Where's the interactions? There's even a pentagram. That's the sign of the devil. I shared that story in the Bay Area, and I'm like, a lady came up to me afterwards, and she's like, about your pentagram joke, I was really offended by that. I'm a witch. I'm like, oh, give me a break. Come on. There's one in every audience. Did I work for you at the USDA? I digress. But then, so the connectivity of that system is what drives function. It's what drives pest abundance. How does that work? Well, we don't always know. In fact, we can't possibly know the complexities of the interaction of that massive ball of spaghetti noodles and how all of those interactions are driving this pest. I don't think that we can. There's not a mathematician in the world that's going to be able to tease the complexity of the natural world apart entirely. And so sometimes we have to take a humble route and just get the hell out of the way. It's not just about numbers, it's about interactions. And here's a great example. So beetles, just like your cows, have in their stomachs a bacterial community. And that bacterial community, or just like us too, right? We have more bacterial cells. We are walking sacks of bacteria, all right? We have more bacterial cells in our body than we have human cells. Beetles are the same way, and when certain beetles have, they're granivorous. They love to eat weed seeds. And so we decided to look inside and try to figure out, for this one beetle, we'll call it Harpalus. It's also a good predator, but sometimes it likes to eat weed seeds. And so we looked inside, we fed it antibiotics to kill all the bacteria in its stomach and then saw what would happen to its behavior. So when we fed it eggs, some cricket eggs, it still loves those, right? There's no difference in the amount of eggs that it eats, whether it's got its bacterial community intact or not. But when you kill off all of the microbes in its stomach, suddenly it stops eating weed seeds to such a great degree. And we narrowed it down. And what happened was one particular bacterium, Enterococcus faecalis, was particularly, when that thing was present, that beetle was a granivore. When that bacteria was absent, that beetle was a predator. And so we think of these beetles as a species, right? Oh, Harpalus is a granivore. Well, no, actually no. Though that species actually has all of these biotypes that live within it. So what happens to the bacterial symbionts when we look inside of our agroecosystems? We looked at all the bacteria living within crickets, and it was the same sort of a situation. These crickets are omnivores. Sometimes they're granivores, sometimes they're not. And here we've got the prairie, we've got the pasture, and we've got the maize fields, the cornfields. And in both cases, we see that there's a precipitous decline in the number of bacterial symbionts that live within the stomachs of these insects. So it's not just about them being there. It's about all of the species that you can't even see that are living within them that may or may not be influencing their function. Suddenly we've got weed problems in our cornfields, right? It may not be an insect issue. It may be an Enterococcus fecalis issue. The complexity of the natural world is profound and unpredictable. And this has popped up time and again. How am I doing on time? What? All right. That's such good stuff. All right, let's talk about poop. Yeah, you're my peep. All right, this is some work of Jacob Pachenka. He's a master's student. He just finished up. He did an amazing job. What we were looking inside of cow turds. There's a lot of bugs that love cow turds out there, okay? 450 species of insects have been identified from cattle dung in the U.S. There's 30,000 species of dung beetles worldwide, and we've got about 1,500 species in North America alone. A lot of people come to me and they're like, I don't have dung beetles on my farm, and I say, I doubt it. I strongly doubt it. But we've got to build habitats so that they can work, right? It's not about numbers, it's about interactions, it's about function. Out of all of those, only 1.5% of those species are pests. But that's what we focus on, isn't it? With dung insects, timing is everything. If you get early colonization of your dung pat, that dung pat is degraded. If you do not hit that dung pat in the first 2 days, that dung pat's going to stick around for an awful long time. That's what this graph is trying to say. I would expand on that if I had another 25 minutes. Why is that important? Okay, so if you get your dung pats out of there within the first 7 minutes or 7 days, you do not have pest problems. You break your pest cycles. A lot of your fly problems, a lot of your helminth parasites are eliminated from your system. All right? So we decided to take a look at this, especially in the light of avermectins, because everybody likes to, or so many people like to treat their cows. And what we found is that management can replace that almost entirely. Okay, so we sampled 16 ranches in eastern South Dakota. We grouped these into regenerative ranches, which had higher stocking rates, more frequent movement, and they didn't use avermectins. They also had a longer rest period. And then the conventional ranches had very low stocking rates, but they left them on there, basically a continuous grazing operation. And then we intensively surveyed the insect communities. Jacob, as part of this, identified over 116,000 insects. We found that there were more than 400 insects per cow pat in this study, and 172 species. To my knowledge, this is the most comprehensive bioinventory of cattle dung ever conducted. What did we find? Regenerative ranches had greater species diversity and species richness. Maggots were significantly higher in the avermectin-treated animals. That's not supposed to happen, is it? It's just like Claire's study yesterday. Why are we doing this to ourselves? Dung beetles were only 1.5 to 3% of that community. And that is another issue, right? We're so focused on dung beetles. We think dung beetles are the most important thing out there. My God, 97% of that community is other stuff. But dung beetles are so important. You want to know why? They drove the abundance and the diversity of the whole entire rest of the community. And that's because they're the early colonizers. As soon as that pat is turded out, it skins over. And the only thing that's heavy-bodied enough to punch holes into it is dung beetles. And so they open up a highway system that allows the rest of the insect community to colonize and tear it apart. It's about interactions. It's spot interactions. Yeah, I said it before, agrochemicals are an addiction. Pests, if you have a pest problem in your field or on your ranch, the pest is not the problem. The pest is the symptom. Solve the problem. Stop reacting. Start designing systems where you don't have these issues. Change the system. Abandon pesticides. That's the first step in this process. It's not, I'm going to use a little less. And it's a painful process sometimes, right? It's a painful process. Just like getting off of drugs. It's not pretty to watch. Next, use high-intensity grazing. Move your animals and allow a rest period. And then finally, integrate herds. Animals did not evolve on their own. They evolved together, right? They work together. Many, many thanks to many, many people. I would not be here without just awesome, awesome colleagues. And none of this is done alone. We would not be here without your support. And there you are if you want to learn a little bit more. We've got these papers are just about coming out. If you want, besides just giving us thousands of dollars, straight up, if you would like a way to support us, we have T-shirts, Blue Dasher T-shirts. They're very fashionable. Those are $25 a piece, and then we have honey for sale at $8 a pound. So, if you would like, most people have never tasted real honey. If you buy honey from the grocery store, that's not honey. It's sugar water adulterated from China and India. So. If you want to try real honey, give it a shot. It's pretty remarkable.
Excellent, thanks. Let's do one or two questions. Yeah.